So we're back yet again, and just a reminder, if you look at the bottom of the video on YouTube, we've got open up the description section down there, and it's got an index of what we're talking about today. And the index becomes part of the chapters at the bottom of the video. So technically, if you click on that, it'll put you into the video at that point to watch it. And then I compile these each week, compile them together into a composite index. So if you look at the link down there, it says the lawn tractor automation something.htm. So there's an HTML file with a composite index that goes back like 4.5 years now. And so if you want to go dig through that, you can pull it up and search it. And um, there's also the index back, the original ROS agriculture stuff. I was just trying to find something yesterday. Was on not something about using RC servos, and I couldn't find it showing up there. And I realized probably what the problem is. It had like 250 videos, and I've gone back and indexed like 200 of those. So the stuff I was looking at was probably in the 50 videos that I have not indexed. So that would explain that. But anyway, there's an index of that old stuff, and that's the only way to get to the videos anymore. They're still out on YouTube, but they're marked as unlisted. So my index there, where it's got a link to it, is really the only way to find them anymore. And but it works just like the modern index for this meeting works, except it's all text based and it's more cryptic to figure out. But it's again a way to make this stuff work. So let's see, I was gonna say, what did I do this week? One of the things, I was playing with my Raspberry Pi, and um, I've got it sitting on the table with a full-size keyboard, a full-size mouse, and hooked up to a HDMI monitor. And I was thinking, boy, it'd be handy if you had a simple way to talk to it. So I ordered up this thing, which is just a cute little board on Amazon, or a little keyboard on Amazon. That's got a touchpad thing here. That's got some kind of arrow keys here, and then arrow keys over here. And then it's got all the standard keys you find on a keyboard. And every once in a while somebody complains, oh, I got one of these, but it needs this key and doesn't have it. So it might run into it. But I just bought this, and this just showed up yesterday. And it connects to it's called a Wi-Fi keyboard. So it's got the little dongle that plugs in, like sometimes you get a mouse or a keyboard, and that thing plugs in to the side of your computer. Well, it's got one of those that plugs into the Raspberry Pi, and then you just turn it on, and it's got a cute it also has a backlight on the thing. And I don't know how well. I guess I could turn the lights off and look at it, but it lights it up enough you could probably run it without having to get too carried away. And I just got far enough. I fired it up and verified it does talk to the Raspberry Pi, and I can type on the stuff, and it shows up like it's supposed to. And I finally realized I have to move this around, put the cursor where I want, and if you tap that, it will take that as an input. Or you could probably hit that OK button there, would probably select wherever your cursor is here, that would probably select it. So anyway, I only played it with enough. I charged it when I got it and verified it'll talk to it, and looks like it does seem to work. So that was something I just picked up and need to go play with it some more. And the other thing on the Raspberry Pi was both Bob and Al had been using that nomachine software to get a remote desktop from a laptop, or I think Bob's got iPad, and he can use either his laptop or his iPad and get into his Raspberry Pi over Wi-Fi or over whatever network you have, and it will then give you the desktop on the remote device. And of course, the simplest way is go down all the way down and run like SSH with either PuTTY or Linux SSH, and run that over your Wi-Fi and get a command line to come up. But if you get in a case where you absolutely have to see what the screen's doing, trying to do configuration or something, it's handy to be able to at moments notice pull up a desktop and control it that way. So I got as far as getting the nomachine software loaded and after some playing around. It does seem to work, and it's kind of like my keypad right now. I haven't figured out what all the little bits and pieces are, and if it's going to work out in the real world. So I'll have to play with that stuff some more. And the other thing I was doing this week, for the last couple of weeks, I think I've been saying I was going to try to figure out how to do power sequencing on my Raspberry Pi. So the simplest way to do power sequencing, you walk up, you plug the power cord into it, it automatically boots up, comes up to a command line and or a desktop. And when you're all done, then you either go, if you're on the desktop, you go to the top and say, I want to shut down the computer just like you normally do on a Linux computer, at which point it'll cycle down. And when it's all done, you can then pull out the power cord. And the other option is you can do that from a command line instead of going through the desktop. So, with the thing sitting there running, you're all done. You go to command line and something like sudo shutdown now, you type in, and it will come out and say, okay, I'm shutting down. And then, after a while it quits doing anything. And then you can just yank the power cord out of it. But I was looking at, how do you have, say, an extra little microcontroller sitting there that I would send it a power up request or a turn on request. And the microcontroller would say, oh, well, I need to check a couple of things. Then I need to enable the power on the converter, which will put 5 volts on the Raspberry Pi, at which point it'll boot up and come up to a command line or a desktop. And somewhere in that process, you can start a script. So it will automatically connect to the microcontroller. So you can either just have GPIO pins talking back and forth and say, I'm up and running, or I'm shut down, or going the other direction. You can have the microcontroller say, I want to request the Raspberry Pi to shut down. So by having some handshake there, people have figured out how to do that. So a combination of the IO pins and some timers, they can make it do fun things. And then likewise, if you want the microcontroller to shut down the Raspberry Pi, it just wiggles one of the GPIO pins and it says, oh, gee, we got a request. And your Python program, then you could say, well, we got a request to shut down. So you could say, do a search of whatever ROS stuff is running and do a kill on that to do an orderly shutdown of ROS. And then when you're done with that, then it can execute that sudo shutdown now thing. So basically, that would all work. And then the microcontroller would be watching that and says, okay, I just see the power just dropped on the Raspberry Pi, which means it went down. And then at that point, you could start another timer like 10 seconds or 30 seconds. When that's all done, just kill the power to the Raspberry Pi completely. And then you're all set for the next day when you want to run it. So you can walk up. Another reason to put a microcontroller on there, because you can program it to do anything you want at that point. So some people will build that and then connect it to their key switch, like in their car. And so you've got the power to the switched power supply goes directly to the battery, and then you've got a line going into the microcontroller that's watching. So when you turn your key switch on, it says, "Oh, gee, he just turned the key on, and is either starting the car or going to start the car." So it cycles the whole thing up, and then it watches. So when you're done, you get to the grocery store and you go to turn your key off. Well, that gives you a shutdown request by turning the key off, but the thing is still directly running off a battery. So it has time to go through and shut the thing down and save all your files, save all your logging files. And when it's all done, it'll just shut itself down. So that's more things you can do if you want to do it that way. Or I was also pointing out that you might want to put like an alarm clock function in this thing. So you can say, well, tomorrow at 8 a.m., I want this thing to boot up and go out and mow the yard. So you could either, in your microcontroller, you could put a software real-time clock, or you could get these external modules. And I was just showing those. Let me see, how do I get that to come back up? Say share screen and go to this screen. And we were talking about this earlier. And let's see, that should be visible. Let me move the stuff out of the way so I can see what I'm doing. Move that out of there, move that out of there. And it says
we have the RTC with the yellow band around it.
Okay. Okay, so this is one of them you can get from Amazon, and it's just a little module that will plug right into a Raspberry Pi. And on this screen, they're saying, here's of the 5 pins, that's what they are. So if you flip this over and plug it into the inside row of the header pins on a Raspberry Pi, and it'll probably work on anything, probably work on all of them, because the original pins were defined. The original thing had 26 pins, later went to 40 pins, but the 26 pins are all the same. So basically you just plug this into the Raspberry Pi, and then you have to get some drivers. So on startup, it goes out and reads your real-time clock. And that way, whether you have an internet connection or not, you'll come up, and the time will be within a few seconds of whatever you want instead of being off by 12 years or whatever every time you start the thing. So that's a fairly handy thing to have. And I was also complaining that see on this particular one, yeah, there's no writing on top of this chip. That's another trick that they'll do where you can't come back and say, oh, but it looked like this in the picture. Well, they just put the wrong pictures on. So this gets around that. They don't tell you at all what it's going to be. So there's question. You look at the comments, and on the other one, well, in general, this one I could put right on a Raspberry Pi, so it would know the time. And then I was thinking I could get a second one to put on. Let's see, how do I get that? That one. So here's a different one. And this one, if you look on YouTube, lots of people are using this one, and it's basically just the same thing where it's got on a bigger board. So it's got this is the real-time clock chip with no crystal because it's got it built in. It's new fancy stuff. It's also got a little EEPROM on the board. So if you want to just store some values out there, you can. And then otherwise, then on the back of the board, let's see on the back. So on the back of the board, just got a socket, and then you just put one of the larger coin cells in it. And on your interface, you got power and ground and your 2I2C pins. And then it's also got this SQW pin, which I think maybe stands for square wave. You can also program that to be an interrupt that comes out. So internally, you can go in and you can do an alarm clock function and say in 1 hour or in 1 day, 2 hours, 3 minutes and 5 seconds, I want you to wake up. So when the clock automatically with no power on it, when that time rolls around, it pulls that SQW pin low. So that's tied back to your microcontroller. You may either want to put your microcontroller into a sleep mode, and then this will wake it up, or maybe your microcontroller is running all the time. It's just simply, it's a way to get a time, programmed into the thing and have it get the attention of the thing. So that might be a case where like talking about that sequencer concept. So if I put the real-time clock on and say tomorrow at 8 a.m., this alarm on the thing is going to go off. It's going to pull that pin low. It's going to wake up the little microcontroller that's attached to my Raspberry Pi. And then it'll say, okay, boot the thing up, and it can boot the thing all the way up. And if you got your scripts set up correctly, then when it comes up, the final thing it does, it goes out to give you a command line. Well, it runs a startup script first. And you could say, well, I'd start the launch file that's going to make this thing to go from a hunk of metal into an actual robot. And then say, since this is Tuesday, we're going to go out to the North 40s. We're going to mow the yard based on that pattern. And then when it's done, it's going to come back and park itself in the garage. And then you could go back and shut the whole thing down and reset the alarm for the next time you want it to run. So I just thinking through all that stuff and trying to figure out what to use on that. And one of the things I was thinking about, let's see, stop sharing that. I was thinking that because once I started looking at the real-time clock and thinking I need to have the microcontroller powered up 24 hours a day, and I was looking at things like, the simplest way to do it is here. This happens to be an Arduino Nano, and it's gonna get this to focus. Come on. I still haven't got this figured out.
It's fighting you.
Anyway, it's like an Arduino Uno, but they just simply put on a small form factor, and it's got a USB connector, and then on the back it's got a FTDI adapter chip. So this works just like an Uno. You plug your USB cable in, you can program it, you can use the serial port on it. But the thing is, if you want to put this in low power mode, and this chip on it happens to be the Mega 328P, P standing for pico power. So this is meant to be something you can put in low power mode. But the thing is, everybody says, oh, well, the first thing you want to do is take the power LED off this board, because if you don't, it's sucking power all the time, and it takes a couple of milliamps. And so they were saying that I think if you just take the LED off and well, let's go to this one instead. This is the other option that I have. This happens to be an Arduino Pro Mini. It's basically just like the Uno, except it does not have the USB connector and does not have that converter chip on it. So that's one less thing drawing power. So they were saying if you take one of these and put this, take the power LED off, and say, put it into sleep mode, I think it would go down to 20 microamps. And the thing would sit there running at 20 microamps until because what you do then is program your watchdog timer and say, I want you to time out in 1 second. And then when 1 second rolls around, I mean, it says they got a command that says watchdog timer sleep or something, and you specify number of seconds up to 8 seconds. And then it executes a sleep command. So it puts the processor to sleep. It basically just stops the clock on the processor. And since CMOS logic doesn't take power if it's not switching, then it drops down. And the only thing running is there's a counter inside to run your watchdog timer. So after 1 second elapses, so when it goes into sleep mode, they're measuring it. I think it would run at say 20 microamps while the thing was sitting there, just waiting to wake up. And once it wakes up, it goes back to full speed and does whatever you want. He was blinking an LED or printing a message on screen saying, here's the time when it woke up, and it goes back to sleep mode again. And so it turns out that if you want it to be even less power, they're saying, well, either pull the voltage regulator off the board, and it's just one of these little tiny, that's a little tiny chip here, like 5 pins on it or something. It's microscopic. You can pull that. They are pulling that off the board and then feeding the power just in the VCC pin. And I think at that point, this got down to, they put it in sleep when they're running 7 microamps, which is almost nothing, but that's just something you can do with that. And what was the other thing on that? Blah, 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 blah. No, I've forgotten. The other thing is if you pull up the schematic for the Pro Mini, it says, it's got a little jumper, a little solder blob on the board. If you disconnect that disconnects the voltage regulator from the whole processor circuit. And I think that's an official enough schematic. So if you go look up a Pro Mini, I don't think I have that here. Anyway, if you pull up the Pro Mini on Amazon, you can either get like an official one, either from the Pi people, or not the Pi, from the Arduino people, or from like Adafruit, or from SparkFun, and those follow the same thing. If you look at it, it's got the little solder blob on the board, and these, which are just a little generic. Here, let's try this again. See, look on the back, and there we go. It just says the simple, and that's basically the most brand name you get. And on the front of it, it has, on the upper left there's a resistor that has a 5 on it. I assume that means it's a 5 ohm resistor. So probably if you pull that resistor off the board, that would be the same as unsoldering that solder blob. But nobody's figured that out yet. So there's right in the middle, there's that 5-pin regulator chip. So the one guy was just taking I think he had a hot air gun and tweezers. He's pulling that off there. And then there's 2 LEDs on the board. You got your original, like the pin 13 LED. Probably if you leave that on there and you don't program that as an output, it's probably not going to be a problem. But the power one's right across the power. So they're saying, rip off. See, right next to that regulator, there's an LED and a resistor that says, I think it's a 1K resistor in series with that. So anyway, that's something you can do on that. And it's stuff I was thinking about, and I just need to go down that path a little further and see if I can get any of this stuff to work. So that's something else I was thinking about, and wasted a lot of time trying to look up all these videos to do this stuff. And I also realized maybe if I'd look at my ST micro boards, which I've got, 4 or 5 versions of those, it could be I can put that into a low power mode, and that will also work. So I need to look at that too and see what I can do on that. And let's see, I talked about the keyboard, talked about nomachine. So before we started recording, I heard we're going to get some words of wisdom from Al on nomachine. So I'm going to say I'm done here, and I guess I'll turn it over. We could turn it over to Al next, I guess.
Well, no words of wisdom, just one thing I had is a problem that I mentioned to Bob. He's trying to use nomachine as well. I was in one location and needed to connect to another machine via nomachine, and I could log in and get to, say, this point where I have a window displayed, but and I could move the mouse, but nothing was able to be clicked. And when I got to a point later, all I really needed to do is send a Control Alt Delete, and I didn't think about how to do that from a remote location. But I guess nomachine allows you to send a Control Alt Delete. I guess this is a Windows to Windows conversation, so not so much for an RPI, but if you're ever to a point where nomachine is not reacting and you can log in, and you can move the mouse, but the clicking isn't working. If you send a Control Alt Delete, I found out that it will sort of wake up what you're seeing is the Windows, and it's as if you were sitting there, sent a Control Alt Delete, and that's all I needed for the mouse to become usable again. So that's just a little bit of nomachine and Windows malarkey going on.
Can you
Back,
go back to that screen where you pulled it up and showed us where that, I want to see where that's located.
so if you up in the top right corner, if you hover your mouse over
Yeah.
that X, you get a little pull down tab. And if you click that pull down tab, then you're bringing up a special nomachine window. And in the lower right hand corner, you get this X. Click on that and you get the Control Alt Delete.
Okay, so while you got that open, see right above that it says send key sequence. So I assume, I was trying to do a Control Alt T to open a terminal on my Raspberry Pi. Probably if you click that, it'll say it puts you in a mode. It's going to intercept the keys and send them to the Raspberry Pi. Yeah, th- now that I know it's there, I'll play with that sometime. But that might be, just instead of the Control Alt Delete, which is already pre-programmed, it'll probably say, "Oh, put it in key sequence," and it says, "Now press the keys you want to send," and that might be how that works.
Yeah, you're absolutely right. Maybe there's a Linux connection with this. So that's what's going on with that.
And
Uh,
I was thinking Linux will honor a Control Alt Delete also. I don't remember what it does, but I think it does something on Linux, I think, too, when you do that. Just another tidbit.
Back to more robots. I mean, I just posted a couple of photos in Slack showing the current state of my electronics board. I've moved a couple of things around, and that's not a lot of progress, but um, used to have my e-stop button over in that lower, what when it's installed, this is the lower front corner, and I moved it up here to the upper rear corner. I thought to just give it some height advantage, and you don't know it, but in my particular situation, this is where the gas spigot comes out. And so, yeah, I think putting this up here is a little bit more good for safety reasons. I was working on the wiring for this JRK motor controller and just went ahead and this is a 5-pin header for the linear actuator, and there's power and ground for the motor, and then there's 3 control signals that go underneath it. I just hardwired that in to avoid having connections and loose connections. Um, the back side of the board at the moment looks like this. So this is where those potentiometer settings or connections are wired in, and wired in the control settings over to the teensy that's here. Now I need to, you wouldn't know it unless I tell you that these are pins for the the motor controller. So I've got to wire those over here to the Teensy as well. This is the back side of the board. One of the things I changed is this is my lithium battery, and I use that hole, and there's a hole underneath this positive used to go through to the outside, well, to the front side of the board, and I took those off. Jeff conveyed to me previously about the safetyness of that, so we can see that that's empty and the negative over there is covered up. So hopefully a little bit more safe. And if I have to charge it, I can just turn on the power and connect my negative and ground to the power distribution board. So just a few changes on my board before I lock it down and pin it down. And that's all I've gotten done this week. Over to you, Bob.
Okay, what did I do this week? Put everything on, mounted on plywood on the robot. I installed the second deck and put the camera up there. I'm going to take the camera off of the little piece of wood that I had and just mount everything right on that upper deck. And I found that things are too close together, so I got to spread them out. Let's see, the other thing, I took the program that runs the servos and just basically copied it and made that my motor circuit.
So Bob, before you go on, this is the deck you were talking about?
Right. Up on top. Yeah, up there. I'm going to pull that unpainted board out of there and just mount everything right on the white board. There isn't enough room on the little one, and it's hard for me to pull the USB peripherals in and out. So I'm going to expand that. Right at the front, you see two terminals with wire connecting them.
Here?
Yeah. That's going to be a space so that I can turn things off and on between battery power and AC power. So right now it's wired up for the battery, so that yellow green wire is coming from the 12-volt battery, yeah, on the lower right. But now I got to come up with a switching mechanism so I don't burn things up. So that's just a spacer for right now. Let's see what else.
Is this the battery or is this a distribution? I see red and white. So is this a power distribution thing block here?
Yeah, for the electronics.
Got it.
And then the other battery is just the drive motor battery. It's just a Barbie Jeep battery, that you drive around with. And then right there in the middle with the green terminals, that's the saber tooth, and that seems to be working pretty good. And then to the left of that, I put in the voltage regulator with a display on it because I wanted to see how much power is getting pulled. And right now, everything turned on, it's only a couple of amps. So I don't have to worry about too much of that. Over there on the right, I used electrical connectors all kind of garbled up. So I want to take that apart and make it a little more organized. But I'm use one series for positive and one series for negative. That way, terminal strips it just kind of get big and bulky with spade connectors. So that seems to be working, but I want to make the wires longer and then secure those connectors so they aren't bouncing around. Let's see, what else? And I've just used my prototyping or breadboard wires. And then instead of gluing them together, I just taped them to extend to the upper end. So I want to replace that, make it a little more permanent. And let's see what.
So you can't see it, but are there two wheels on this board? I mean, I see these casters.
Yeah, underneath. At the
You're-
front part, you'll see two little blocks.
I see these look like caster wheels.
Yeah, they are. And then the barbie are underneath the front end on just back of that. Let's see if I don't think I've got a picture of it. Oh, maybe I posted a video clip yesterday showing it everything working. Kind of, sort of.
This?
Yeah. Yeah, that's it. Okay. Okay, now the camera is in a fixed position on that upper deck. And the movement you see on the screen is the result of the motors going around. But I'm always, what I get mixed up on is that I have to have the terminal on the Raspberry Pi engaged to accept the keyboard commands. And then the key presses will control the motors. I think I've got another video of it spinning around in a circle, but I have to drive it like a tank with two keys, and that's just a pain. So now I want to put both that motor code and the servo code together so they multitask off that keyboard. So let's see, are there any other? No, that's about what I got. Got them. The other thing I've noticed, if I turn everything off and start up, start turning on the power, the wheels go crazy. And which is so I hit my remote stop key, this little fob. So I turn it off first before I do anything. And then now I've got it up on some spacers off the floor so I can kind of look at that problem. Let's see, I'll take the iPad to work too. Let's see. Oh, I got to really get. So there's the Barbie motor underneath. Yeah, there it is. That's at the front end. So that's about it.
You have a teleoperated robot with a camera mounted on it, Bob. That's fantastic.
Oh, but it's crude. I mean, you have to drive it like a tank, and I don't want to do that. But I'm still messing around with the servo control program, trying to get it spaced out so it behaves more like a motor circuit rather than a servo circuit. So I'm extending the cycle and reducing it sometimes, but I don't Next time I'll explain it a lot better. But that's about where I'm at.
I think that's great. I could use that in Texas right now. Be hunting armadillos with that thing.
Yeah.
Since we're talking about pictures, if on Slack, if you go to the top and just click on files, it gives you a nice, it pulls up all the images and everything, puts them on one screen where you can see them, and it makes it easier to see what's going on. I had the message up that you were just playing with the video, and you then click file at that point, it gives you like 4 or 5 things that are actually related to what Bob's doing. And then there's a thing that says show all. You click that, it brings up everything back for 90 days. It shows you all the stuff. And then I was thinking, because at one point he was putting pictures of his wheels, like instead of having to drag the camera down like he was just looking at, there are images on Slack, but unfortunately we'd have to go to a Slack backup and go back 90 days. So because they seem to have disappeared off the main one right now. So it's just in the future when somebody says, I think there's something on Slack, that's a quick way to find all the images that are posted. And I assume it's got, it looks like it has videos are showing up there too.
Yeah, I got to get more organized with my pictures, and like you say, make a folder, put them all in there, and so it's isolated.
I'm just thinking, during the meeting when somebody says, well, I did this once. Well, it's if you're paying attention, it doesn't take that long to go back and find, what people were talking about. So that's just something else to keep in mind.
Right.
Now, if you got the Slack backup displayed, I don't know if there's a convenient way to just say, show me all the images by using that. So I don't know if that would work or not. So.
Well, I noticed on the video that I posted yesterday, there's a message at the bottom of the screen that says, no, he's got plenty of rest and stuff. What I didn't realize was that the microphone was on when I was shooting the video of the robot. So now I got to make sure I close the door to the room and turn off the microphone so that we don't hear what's going on downstairs.
Yeah, I saw that pop up there. What is that? Yeah. I went and played it. I realized that's what's happening. It's hearing people somewhere else in the house and recording them.
So I didn't have enough time to reshoot it or anything, so I just put in the disclaimer at the bottom. Another lesson learned.
Well, you're making serious progress, Bob. Quite honestly, I feel like you're ahead of me.
I don't think so.
That's all I got.
Yeah, me too.
So last week I was saying that when I was digging for the motor control stuff, and I said I keep running across this thing where they're talking about using an RC servo to control a big motor driver. And when I was digging through my box, I found here is a standard size servo that I tore apart one time. I took the back cover off here, and on the front this is where all the gears were, and I took all the gears off, and they probably got lost. But sticking up right here is the lighting kind of bites. But anyway, that's the top of the pot right there. So the pot turns back and forth. That's your positioning. And so what you have to do is you have to everybody says unsolder the wires to the motor. So that's these 2 tabs sticking through there. You can unsolder that. And I think you can probably pull the motor and the board out. I just need to find a screwdriver and pry on that. But when you're done, you'll just have a flat printed circuit board. It's got your RC wires coming in here. And then the 2 wires that normally go to the motor, you just run those out, plug them into your motor driver board, and then hook it up to your big motor. And then you should have doing that should give you a speed control mode. So you run your RC and it runs your speed forward and backward at whatever your joystick is set at. And then the thing is, when you first do this, you hook it up and put it on something with a reference, either like Bob's doing with say put out the 50% PWM, which should center it, or if you have a say a radio control transmitter with spring return to 0, just leave it at 0. And when you turn it on, the motor is going to be turning one way or the other. So then you have to grab the pot on the board. And again, it's just like a kind of a double D shaft sticking up.
Yep.
There it is. So anyway, you grab that and you turn it. You turn it one direction, the motor is going to go faster. You turn the other way, it's going to slow down. When you get right to the center, the motor should come to a stop. And then at that point, that's how much calibration you got to do. And then from then on, it should work just like, you know, a radio control speed controller. And if you get to the point everything's working right, then you could just put a blob of like hot glue on that or something, so the thing doesn't turn on you, and that way, so you don't bump it and then have it wildly driving around. Another thing I was thinking about, so if you go in there, and if I had this out so you could see it, you know, that pot is just soldered on the board. You could cut the wire between the pot here, and then run 3 wires. So get power, ground, and the signal, and run them out and put a pot right on your big motor, and then hook them up to this thing. And then basically you've created a giant RC servo. So it should be able to do positioning then at that point. And that's, you know, that's all speculation, and it all comes back to the fact, you know, it's got this little tiny motor in here, and you can even get the micro RC servos that are, you know, a fraction of this size, but they've still got some kind of a board you can pull out and do the exact same thing with them. So based on the dynamics of the motor, this little tiny motor, it's all tweaked, you know, to make this work well on, say, like radio control airplane applications. And if we now put say a 0.5 horsepower motor on it, it's going to act differently. So that'll just be some experimentation to find out, you know, how well is a big motor going to respond. And if we put a potentiometer on the big motor, you know, will it give you decent positioning and not chatter and not lag and not break anything? So that I got that far, and I guess I could have continued on this. I just didn't have the ambition to pry this out and play with it, because that's what I got to do is just you might even be able to leave this motor hooked up. I haven't seen anybody doing that. Everybody always says they say get an old broken servo. Well, they're cheap enough. This was a brand new one I tore apart. So I don't know if they paid $3 or $5 or something for it, but you can take it apart and then pull the guts out, and that gives you the conversion between the RC signal coming in here and your motor. So that's worth at least exploring to see what's going on there and see what we can do with that. And then when I get back to motor control, I was thinking, say, if you got a big ugly motor like those power steering motors that like Al has one bolted on his lawn tractor, I bolted on one on mine, but I haven't got the electronics running on it yet. But on those, say if you run it all the way to one side and you give it a step function, so you go to the other side, if you don't have any speed control built into it, the thing is going to be like this, and it's going to go wham. It's going to give it full power, and it's going to start smashing stuff. So I'm thinking, well, just put 2 or 3 extra lines of code in there. So, and say if you're watching on your signal, you come along like this, and you give it up here, you give it a step function. That thing is going to see that and try to do everything it can to get to that point as fast as possible. So what you do is you put some lines of code in. So you come in like this, you give it the step function that comes up like this, but then have a thing that ramps that starts going. So it starts going up like this, and that will control the speed of how fast the thing will turn. So instead of coming along like this, get a step function, the thing goes wham and goes to the other side and bounces around. And so instead you control the speed of that. So it'll come like this, get a step function on, it go rear, and then come to a stop up here, and then go and come back down. So that just with a few lines of code, you can make it do that. So that's something else we can experiment with, and especially on the big powerful motors, because the other thing is, by doing that, you're creating the little stair steps that are coming along here, and so now you're only trying to control from this point to this point, as opposed to trying to go from, you know, one end of the steering all the way to the other end of the steering. Because in that case, it's saying, yeah, that's I'm going to do everything I can, give it all the power in the world to get there. And if you're just controlling, you know, just these little micro steps, you can now crank the motor power up all the way, because it can't get away from you, run all the way to the other side, because you're only moving it, you know, a few degrees at a time for each step. So that will also, I think, improve the overall control of the motor, because now you can have you can be generating tons of torque and not have to worry about the thing running away from you. So as I say, when we get that far, we can add, I think it's just 2 or 3 lines of code to make it do that. So that would be something else we can look forward to at one point. Oh, so even on that, say if you've got something like this that does not have any speed control built into it, back at this level, where you're coming in with a signal here, you can just in your code, it says, okay, I want to go from full left to full right. So just in your code, you can say, generate the PWM numbers. And then as you do that, so you're controlling it in software as opposed to doing it in hardware. But if you do it in hardware, then you got a better chance of, preventing something catastrophic from happening. So like the case where Bob's got his little PWM board running, you just simply, instead of going from, say, a value of 10 to a value of 500 or whatever the numbers are, you just have a loop that says, okay, I need to go from 10 to 500. But each time through the loop, I'll say, okay, just add 2 each time. So go 2, 4, 6, 8, 10, 12, until it gets to the point. And then by doing that, by controlling how the size of the number you add to it, you can control the speed that it's going to take to go from one end or one point to the other. And it should, once you get that point, then it should just automatically take care of itself. And then back to my point about, we could take this RC servo and hook it up to a big motor and make it act like a RC servo. And I'm thinking, well, but I keep wanting to go back to using a microcontroller to do it, because one other feature you could add is when the microcontroller comes out of reset, it goes out and says, read the position of the steering, which might be all the way over here. Say, read that position up. And then since we're at reset, we're going to say we want it centered. So again, instead of doing a step function, we're going to wham and go back to the center like that, which is what the RC servo stuff would do. Again, we can say, oh, those don't match. So let's go into a slow speed mode and do a slower. I'm just going to go brrrr till it gets back to the center. Once you get centered, and so, okay, now we're set. So now don't do that forced speed control anymore, or we can just change the speed control value to whatever you want for, normal driving around, so you could have 2 different things there. When you first turn it on, it would just go through a thing that says, let's just gradually put it back to where it's supposed to be and not let it slam around. And then we can just have the other overall speed control that says, we've decided that these are good values for making the steering work. So again, that's just more stuff to talk about one of these days and see if we can make that work. And one of the reasons, another reason I didn't get around to doing this, I thought, boy, if I had a big motor that's got gear reduction that I could put a pot on to experiment with, I could try this. And I realized, well, all my motors are over in storage, so I'm going to have to drive over and dig through the box that says big motors on it. That's one of the places where the big motors are. So I can either do that, or I've got one that looks like a windshield wiper motor, but it's a bigger version of that, and that one would be good for experimenting. Or I've got, I could, if I'd go over there and unbury my lawn tractor, push it out into the hallway, and then I could take the power steering motor off that and bring it home. So that's another thing. I could get the actual power steering motor, which is going to be real close to the final product, since that's what Al has on his, and that's what is bolted on mine at the moment. So that'd be something to experiment with. And at one point I made that board where I had that mounted on the table to experiment with, so I could get the motor and put it back on that, and then go from there. So that's kind of where my life is at the moment. I just have to make a journey over to my storage unit and dig through and get some stuff out of it. So I think that's all I got to say for the moment.
I'm all set as well.
Yeah, me too.
Okay, so let me hit the stop recording button.